LARSA Section Composer is a powerful and easy-to-use graphical tool that creates built-up, non-prismatic, and composite sections based on standard, parametric, and custom shapes. Sections are typically created by adding shapes from the extensive shape database. From the database, a standard or custom section can be easily added with the guidance of graphical preview for the shape, shape dimensions, and section properties. After selecting the shape in the database, it can be brought to the canvas by simply clicking the Add button. Alternatively, shapes may also be drawn directly within this canvas. To draw a free shape, the Free Draw tool can be selected from the toolbar and the shape can be drawn by clicking in the canvas, guided with grid lines and a header bar. The points coordinates of the drawn shape are viewed and edited from the Points tab. They can be quickly edited entering a numerical value, formula, or predefined parameter. To generate parametric shapes, new parameters are added in the Parameters tab. The parameters name, value, and unit type are all defined here. After defining parameters, the coordinate of the shape's points can be made as dependent to these parameters. If the section dimensions need to be changed, modifications are made through editing parameter values instead of through editing each point's coordinate. Similar to drawing free shapes, in this example we'll create a hollow rectangle using the Free Draw Cutout tool. After analysis, member stress results can be extracted from predefined stress recovery points. These points are easily defined on the section by right-clicking on the desired section point. Built-up sections are created by adding more than one shape and arranging the alignment of shapes with simple alignment tools. To locate the shapes on the canvas, we can hold and drag, or we can use the alignment tools. Alignment tools allow bringing the selected shape to the desired position with respect to the member reference axes or to the other shapes. To connect the certain sides of shapes, the Snap Shape tool is used. The selected built-up section's centroid can then be brought to the member center. In this section, we can see the member reference coordinate system. In most cases, the member reference coordinate system coincides with the member local coordinate system. They only differ when a member has been assigned a section created in Section Composer with a centroid that's offset from the reference coordinate system. In this parametric shape section of the Devil's Slide Bridge from Caltrans, a physical offset for members can be defined explicitly in Section Composer with respect to the member reference line. Centroid offset from the member reference line can be seen here. By switching to the model's complete rendering, we can see the 3D view of this section in LARSA 4D. In LARSA, the orientation of the section can be controlled by entering an orientation angle for member elements considering their local coordinates. The member reference line lines up with the line between the start and end joints of the members in the LARSA model. Members are displayed as their centroid lines rather than the member reference line in LARSA 4D. This indicates centroid offsets from joints of the members unless the section centroid does not coincide with the member reference line. LARSA's Section Composer automatically calculates the section's properties as they're created. The properties of the section on the canvas can be viewed on the right-hand side of the Section Composer. The section properties are updated during the process of creating the section by adding and locating each shape on the section canvas. Should any modifications be required, such as needed to consider the crack moment of inertia, the editing of calculated properties is quickly entered through the property modifier. It's also possible to generate fully composite material sections. Sections that are composed of parts containing different material properties account for different effects, including self-weight, thermal loads, and time-dependent material effects. In LARSA, these stresses are reported in each material part. Steel rebars can also be simply defined inside a concrete shape by using the Draw Rebar tool. After specifying the necessary information, including their material, rebars can be fit inside the main shape. Composite material sections can also be created using the shapes that are embedded within other shapes. To do this, we simply insert a composite subshape inside of the main shape. The materials for each composite part can then be defined in the Section Composer. For the composite material section, a reference material has to be selected. The section properties of this composite material section are computed relative to the specified reference material. Composite subshape generation can also be used to define confined and unconfined parts of the section, supporting the moment curvature analysis tool of LARSA 4D. We hope you found this video helpful, and we welcome you to contact us if we can provide further information or assist your project needs.